it?
Okay, welcome everyone. Sorry for the technical delay. Today's session of the HIF seminar will be on a topic that is unusual for our field. It's about the relationship between set theory and logic and economy. So I see that the title is different from the one I have, but anyway, Linking Set Theory to Economics by Professor Adrian Mathias from Université de la Réunion.
Thank you. Well, Benedict asked for a talk that was not in final state and would provoke discussion, so I feel this is just the thing. So I've given you a handout. On one side, there's a list of books and papers, which I shall mention at various points. And on the other side is the first page of a paper that's very much in draft form. And anybody who's interested in seeing more of it and discussing it with me, I'd be delighted. Now, the story begins in 1986, when I was told in Cambridge that my lectures on set theory and logic were not needed because undergraduates could get everything they needed out of Bourbaki. So that's when I read Bourbaki's book on logic and set theory, and I was shocked. So I wrote a paper called The Ignorance of Bourbaki, which I was told I couldn't publish because I'd be murdered if I did. But a time came when I had no more to lose, so I published it anyway, and had a very pleasing response. And yet some years later, I got to Réunion, that is a French island east of Madagascar. And my colleagues there drew my attention to a strange thing. In France, if you want to teach in a French school, you have to pass an examination called the CAPES, Certificat d'aptitude professionnelle de l'enseignement supérieur. And there's a syllabus set out, and in the mathematics section, it had a line, tout exposer de logique formelle et exclu. So logic is no logic. So I began to suspect this might be linked to Bourbaki's attitude to logic. So I started to investigate, and news may have reached various people in Paris that I was investigating, because a few years later, this line was toned down to aucune exposé de logique formelle n'est envisagé. So that led to a very long paper, which has just come out last year in Singapore, published by World Scientific in a volume edited by Hugh Woodin and C.T. Chong and Ted Slayman. Your co-editors of the volume. Yes. And when I was researching for this paper, one of my correspondents told me that the archives of Bourbaki, or at any rate some of them, had been put online. So I had a good rummage. I'm afraid I'm a marked man where Bourbaki is concerned, but a friend in a false beard went along to the archives for me and dug up a bit more. And I learned that there had been a plan for André Vey and Pierre Samuel, I think, to consult Barclay Rosser about their book on logic, because Vey was in Chicago and Rosser was in, I think, Ithaca, not far away. So Rosser by then was dead, but I found he had a son, also called Barclay Rosser, who's an economist. So I wrote to him to say, did your father keep a diary or are there some family records to show whether this meeting took place? And I had a very nice letter back saying, no family records. But did you know the economists are discussing the ignorance of Bourbaki? So I said, tell me more. And this, as I've said there, there's a group of economists. Now, the leader of the group, Kumaraswamy Velupillai, since then, alas, has been in very bad health. He might even have died. He had a heart operation which was botched, and his doctors told him to stop working. So he had said he wanted to republish my long piece in another volume to be published by World Scientific of Singapore, but intended for economists, and he was going to add an introduction explaining why the thoughts of Chairman Mathias are significant. So I therefore started to try and learn something about economics, because I was curious to know whether my reasons that I had for criticizing Bourbaki, which had nothing to do with economics, were in any way linked to their feeling that the influence of Bourbaki has led mathematical economics in the wrong direction. So the problem seems to be linked to André. The two most pushy members of Bourbaki were André Weil and Dieudonné, who had the loudest voice and therefore tended to win the argument. They both believed that all important mathematics was covered by Zermelo's set theory, and they wouldn't need the axiom of replacement. But as everybody here knows, of course, Skolem and Frankel spotted the weakness of Zermelo's set theory and added principles of replacement or correction. So I had the feeling that it might be that the mathematics supported by Bourbaki only covers part of the mathematics needed by economists. And in particular, Velupillai and his colleague Zambelli have been writing about applications of recursion theory in economics. So I'm now, all the rest of this talk is me groping in the dark. Go back to the Greeks for inspiration. They divided geometry from arithmetic. And I thought this division should be looked at anew. So this is where I introduce the two new words. They have actually been quite a help to have these two words to label two areas of mathematical thought. I think of them as naming two different methodologies. I think that's a good word to. I do not assert that all mathematics is one or the other. I think that would be rash. But I do like the idea that there's two areas, and one of them is where Bourbaki were, and set theory is somewhere else. Sorry? Exit. And in the tropics. Well, the tropics foster growth, yes. Right, so to outline roughly what I have in mind, the endometric corner, it's structuralist bit, what Bourbaki McLean are interested in, part supported by Zermelo's set theory with choice. The area where up to isomorphism is good enough. So what I call the top-down part of mathematics. You start with whatever is out there. So those of you who believe in the existence of a physical universe, so see where you start. So it's what John Bell calls local mathematics. Whereas the exotrophic corner, that's the school of Jensen, the heavy emphasis on constructions, recursion theorem in various forms. There was a remark by Gödel that a set is a collection of previously obtained objects. It's not a set theory is not concerned with dividing the whole universe into bits. Now, there's a remark of Dieudonné that we have not yet begun to understand the relationship between conceptual mathematics and combinatorics. So I think this might be related to this split that I'm trying to identify. So the split between set theory and type theory may again be related. Now, recently Randall Holmes has announced a consistency proof for new foundations, which so far seems to be correct, but I think there's more to come. So that will be somewhere in between these two. But I have no idea where that fits in my picture. Right. So we get this Jesus Huerta de Soto is a Spanish economist and written a book about the Methodenstreit, that is the battle of different methods in economics. The Austrian school, Ludwig von Mises and friends, it's not every Austrian economist is actually Austrian. It's just the name of the school. And they are very hostile to neoclassicals. I have there's a delicious quotation from Thorsten Veblen in the paper he wrote, Why Economics is Not an Evolutionary Science. The hedonistic conception of man is that of a lightning calculator of pleasure and pains who oscillates like a homogeneous globule of desire of happiness under the impulse of stimuli that shift him about the area but leave him intact. He has neither antecedent nor consequent. So that's the neoclassical attitude. The Austrians are very much against that. Weintraub's book, How Economics Became a Mathematical Science, there's a statement there from Volkmann that physics is not bottom-up. Weintraub there's a German Theo Duper who's in Hamburg, I think, and he has written about Bourbaki and economics from a phenomenological point of view. And he and Weintraub have written, I've listed it there, there's a joint book, which is rather disturbing. It's about the Nobel Prize. So Gérard Debreu was the French economist who was taught mathematics in wartime Paris by the Bourbaki group, and then went to make his career in the US and wrote a book called The Theory of Value, which came out in the late 50s, and you can see the Bourbaki influence in the way he does his mathematics. And got a Nobel Prize. He and Arrow and Debreu had a result, and it was also discovered by Mackenzie, and the first two got a Nobel Prize for it, and Mackenzie didn't. And what has now come out is that Mackenzie's paper was held up by the referee, and the referee was Debreu. So not a nice story. And then I mentioned the good guys down there. Xu Hengchen is in either Taiwan or Singapore, but he's linked to this. He's the man there who's supposed to be supervising the publication of the economics volume in the World Scientific. But they've gone off the wire. Now, where am I? I mentioned here Hayek, Friedrich von Hayek, who, well, he started as an economist, but his later writings, better to call him a social philosopher because he's speculating more widely than that. There's a rather pleasing picture of him in the war. He had been at the London School of Economics, and then they were moved to Peterhouse in the war, but Keynes arranged for him to have rooms in King's, and so it is said Keynes and Hayek together were on the roof of King's Chapel looking out for bombers and arguing non-stop about economics, because they took different views about the nature of economics and so on. But I think this, oh, sorry, I'm trying to, how do I get a, so there's a very good passage of Hayek's about scientism. It echoes a statement made by the founding president of the American Association for the Advance of Science, who's called Beach, I think, who talked about modified charlatanism, which he said is what happens when somebody who's an expert in one field claims to be an expert in every field. And you don't have to look far to find examples of this phenomenon. So this again is just an echo of this distinction I'm trying to make. Now, do I? So I'm going to give, just so that this talk has some, if rather simple mathematical content, I'm going to give you two examples. So Bedinian philosophers is a problem, I think it's popular with computer scientists. It's about allocation of resources. And I heard about it when I was working for Richard Platek for limited engagement in his, it's not really, it wasn't a software company, but they were thinking about computer security, and I couldn't think why in the mid-80s. Nowadays, it's rather plain why that's important. So you've got philosophers, end philosophers sitting around a table, and there's an infinite bowl of rice in the middle, and they have chopsticks, but only end chopsticks. And to eat, you have to have two chopsticks. So what you want is to work out how the philosophers can all eat repeatedly, so without any logjam. So I suggested this. Some of the chopsticks should be gold and some silver. And there's one between two. So when you have a gold chopstick at your right and a silver one at your left, you can pick them up and eat. When you've had enough, you put them down the other way around. So the gold would circulate one way and the silver the other. And then it's a good exercise to prove that there's no deadlock. Sorry?
They don't mind sharing the bacteria.
Oh. Economics cannot consider every aspect of existence. Does it get nowhere? So the point I want to emphasize here is that provided everybody follows that rule, you don't have to know what other people are doing. You just wait till you have the conditions for eating. So you don't need one person supervising the whole thing. On the other hand, there's the babysitting problem. Now, I've got a very simple version over here. Krugman has written at length about it. It happened in Capitol Hill in Washington. Lots of people with babies, and they tried to have an arrangement for sharing babysitting problems, and it got into difficulties. And Krugman maintains it was solved by printing extra coupons, allowing people to. So I was just concerned with this very simple question: is it possible to find a rota No.
Sorry, what's a rota?
You've got n couples, each with at least one baby.
Yeah.
And at the beginning of the season,
Sure,
six
sure,
months,
I
yes,
read
read
that.
all that, right. So a rota means an arrangement. You know, this couple will sit for that
Okay.
couple on the
language?
sorry?
Oh, yes. Timetabling.
Timetabling.
Oh, like your own tube shit.
Oh, you don't know about rotas?
Never heard of it.
Oh, well, that could explain a lot. So, if there's one couple whose demand exceeds the sum of all other demands, no rota is possible. And that is the only condition. If there's no such couple, then there is a rota. Now, I've written out a proof in that paper I mentioned. It's on page 30 or something like that. I'm afraid I haven't put it onto a slide, but it's fairly easy. But if you say, if you've got 6 couples and they have demands like that, there's a rota meeting with demands of all 6, but not any subset. Take it. So you need to know all the demands of all the couples before you can work out if it's a rota. So here, global knowledge is essential, whereas in the dining philosophers, it wasn't. Now, oops, what's next? So, top down is, as well, the Marxists start with the state, and then bottom up starts with the individual. But of course, there are intermediate structures, and not much seems to have been written about them. This is where, of course, my ignorance is going to show, but it seems to me that if you allow the family regiment university these intermediate structures, you're going to get a lot of interesting questions. So I'm now going to look. This is Oman, who I learnt about from Menachem. He wanted to know a PCA is pi 1, 1. No, it's sigma 1, 2. And CPCA is pi 1, 2. So he's interested in whether every sigma 1, 2 set is a big measurable, because if all sigma 1, 2 sets are the big measurable, he has a nice theorem about utility functions. So I'm wondering whether the, of course, if V equals L, it's false, isn't it? There's a delta 1, 2 well ordering, so it can't be. So perhaps the crises in Western economy is evidence for the axiom of constructibility. Now, there's a pupil of his, Eugene Wesley, who has taken it further and has used ideas for constructibility and forcing to prove results that he wants. And if you've been reading my papers about weak theories, I've got arguments to show that Semela does not support the theory of forcing not without a lot of extra work. Ditto constructibility. And it might be, again, I'm just guessing, that's why, well, Bourbaki-approved mathematics can't do the analysis you need for this particular problem. So Eugene Wesley. Now this, there's the paper I mentioned, Borel preference orders in markets with a continuum of traders. It's generalizing a result that goes back to von Neumann, and you can get a very easy proof of von Neumann's result by remarks from forcing. The function, Borel measurable function that picks witnesses for almost every argument. You just look at the random reals over a countable model and pick a name for the witness. And then the function that evaluates the name given a different random real is Borel measurable. So, Kai Hauser said he thought the right theory for economics would be ZFC plus projective determinacy.
The right theory for everything.
Who am I to disagree? So let's just mention now an economist in Belgium who found that non-Ramsey sets come out of assumptions in economics. I've listed his papers on the handout that I've given you. SWR is a social welfare relation, otherwise called Pareto preference orderings. And this relates to work on chameleons. This is a paper I hope is approaching its final stage, so you must all press me hard to finish it, by Carlos de Prisco, Nathan Bowler, and Christian Delamay. Marianne Morion has withdrawn from the list of authors because her observation has been separately published. So let's have these slides were prepared for a non-set theoretic audience, but you will find it very easy. So we've got the Ramsey property in Solovey's model. All colorings are Ramsey. Now I want to introduce some equivalence relations. Twiddle sub star, if their symmetric difference is finite, and call the coloring invariant if it doesn't change when you make a finite alteration to the argument. And I write that to mean as all invariant colorings are Ramsey. Now, Christian Delamay found a nice algebraic translation of this. So for k is 0, 2, 3, or any other larger integer, I write zk for z stroke kz. So z0 is the same as z. And the additive group is, as you all know, cyclic. And then corresponding to that, I want some more equivalence relations. B twiddle sub 0. If B and C have finite symmetric difference, and there are just as many members in B, not in C, as there are in C, not in B. So that's a refinement. And for K, at least two, I mean, B twiddle C if B minus C is equivalent to C minus B mod K. So each twiddle star class is the disjoint union of counter many twiddle 0 classes, and for K bigger than 1, exactly K many twiddles K classes. So in my thesis, I had the case K equals 2 for getting a non-Ramsey set. Now a K chameleon, reunion is full of chameleons, and they change color. I had a hard time one morning trying to photograph one because it was on green grass looking green. By the time I got my camera, it just got worried, so it moved on to dead leaves and turned to browns. I've got 2 photographs, and it's almost impossible to see where it is in both of them. I'm told you can play a nasty trick on a chameleon by putting it on a mat which has a color which is not in its repertoire, and it will cycle through its colors all the time trying to find. So here, the K chameleon, the idea was originally you color the infinite subsets of omega, and every time you take something out of a set, the color changes. But here we've got a cyclic condition as well. The colors cycle. So if chi is the coloring, if I add n to A, the color increases by 1. Modulo k, if k is positive, or if k is 0, it's just, so k chameleons are non-invariant k colorings with further properties that have a cyclic property. Their existence follows some weak forms of choice, since a k chameleon exists if and only if there's a selector for this family. Oops. Now I've got to go on. Right. So if I factor the family of infinite subsets of omega by twiddle star, that's what I call the Hausdorff extension. It adds, there's a lot of nice papers on, it adds a Ramsey ultrafilter. And if all sets are Ramsey, it doesn't add any new set of ordinals. So any extension of that partial ordering to a line, I'll call that a Hausdorff line. And if k is finite, is bigger than 1, then from a Hausdorff line you can get a k chameleon, because you can get a selector easily, because if you've got a linear ordering of a finite set, it will have a first element. Thesis written in Singapore under Hugh Woodin, 2012. If you've got AD plus DC as well, then if all invariant colorings are Ramsey, all colorings are Ramsey. And I think it's still open whether you can do it without AD. And Nathan, 2 years ago, proved that, if all invariant colorings are Ramsey, that rules out chameleons. He first did it with 2 chameleons, and I had an argument that if all invariant things are Ramsey, then k chameleon for another k would give me a 2 chameleon. So the cyclic non-invariant colorings are ruled out by that. So that's perhaps a hopeful sign that one might be able to drop AD from the proof. Show's proof. All right, so now we come on to, I mentioned, yes, utility streams. Is that right? Yes. So I want to connect chameleons with the work of Lars. So I've put the definitions very boldly here, just looking at infinite streams of zeros and ones, so something like subsets of omega. So his a social welfare relation. Do you prefer one stream of choices to another? That's the question. And the various conditions should be considered. And I'd love to know if there's a particular kind of social welfare relation which is equivalent to the existence of a Z chameleon. So a Z chameleon, or zero chameleon, you've got a map, the colors are all the integers, positive and negative. And if you take an element out, you reduce the color by 1. So it seems that constructing a Z chameleon needs stronger amount of choice than K chameleon for K finite. But I don't think I can yet make an actual theorem about it, but I think there is, it looks stronger.
Finally equivalent means
finitely many changes, yes. So it's like
less than and less than or equal to, or the lexical in 4 and 5.
I think so. Oh, help. Yes. I think yes. If you think in terms of subsets of omega, that means subset, and this one is a proper subset. I think he's interested in looking at streams of more symbols than just 2, but then you'd have to be more. Let's see. Now, there's two observations here. If there's Hausdorff line, then you can get a pure social welfare relation. So remember I said that every Twiddle star class is disjoint union of Twiddle's naught classes, and they have a natural ordering in type Z. So if you expand each of those, so I've taken the Hausdorff line and replaced each point by a copy of Z, and then that will give me what I need, and I nearly get a converse, but not quite. So ideas are invited so that if there's a pure social welfare relation and a Z union, then there's a Hausdorff line. Now, I think I reached the end. That's the last slide. So I was going to read you. Where's that gone? Well, if you find, I'll just read you a few polemical remarks just to entertain you. If I got interested in this, I led into thinking about economics because of the unexpected link with Bourbaki's misdeeds. And it was very invigorating for me because I spent all my life inside mathematics, and I suddenly come out and find there's a lot of thought going on which is not mathematical, but which is certainly involving logic. And I think Keynes said if the Great Depression was a crisis of abundance, not a crisis of scarcity, and I think that is not a mathematical judgment. I mean, it shows insight, and there's a lot of thought going on, but it's outside mathematics. And the logician in me says, can you define where mathematics stops in economics? And I haven't got very far with that. Nearest I get is thinking that economics is, a lot of it is concerned with how people behave. And Veblen satirized the Homo economicus who makes instant evaluations and acts accordingly. And it's a bit alarming looking at people walking around today. They seem to actually behave like that. They're involved with consumption and not much else. People say that today politicians don't represent their constituents, they manage them. Similarly, news is no longer reported, it is management. So given the lamentable consequences of this culture of management, which I think is bedeviling universities, there's a challenge awaiting attention to explore new models of behavior. So the problems of economy are not mathematical ones. As at bottom, the issue is how people behave, how banks behave, how chief executive officers of multinational companies behave, and so on. So economic models make assumptions about behavior, and deciding whether or where the assumptions are false is not a mathematical question. There's a paper, I haven't got it here, but Van Berg has written a paper, Why Economics is Not Physics. Adam Smith, being a bachelor, may well have seen human interactions in a different light from that of Sebastian Bach, with a large family to consider. Schumpeter wrote of Keynes that he was childless, and his philosophy of life was essentially a short-run philosophy. I sent an extract last week from some newspaper saying that companies are desperate to find new recruits who can actually do some mathematics. And not only in England, in many other countries, there's complaints about teaching of mathematics collapsing. And the view I've come to, which I argue in that long paper that I've cited, is that the problem starts with neglect of the teaching of logic. And where I'd like to see some agitation is getting that moving again. So at that point, I think I'll stop. I've just given some vague ideas, and if anybody wishes to pursue them with me, I'd be delighted.
Thank you very much for your talk. Any questions or comments?
So,
So there were the two connections of set-theory economics. There's the Alman, in which it seemed like it was a good thing that all delta 1, 2 sets were the big measure.
yes,
And then there was this other one where it seemed like it was a bad thing.
it
that they
denies
all have
choice.
density properties.
Yes,
So
yes.
I don't know, what exactly is the connection, or can you say more about what the connection to actual economics
Oh, I see.
and social welfare relations, for example?
I think Lorenz was just saying if you they're hard to construct, I think, and if you have them, if one exists, then there's a non-Ramsey set. So I think he's just making the point that the axiom of choice is involved in constructing them. So if you're unsympathetic to the axiom of choice, then well, if ZFC plus PD. Isn't that right? He's just saying that social welfare relations.
Economic theory rests on these answers to 1, 2 sets having these regularity problems.
I think the economic theory of where there are a continuum of traders, yes, it does. But if that is, to what extent is that an accurate model of a finite population and its behavior?
It's not a bad model.
It's not a bad one. Okay. I wanted to provoke discussion. I didn't want to.
It may seem rather flippant to think of the remark that you made about Keynes' interest in the short run. His book, which was very influential, his trip to Russia in the 1920s,
Yes.
influenced Wittgenstein and other people, and probably Blunt and others, was based on a very short run in Russia. It's
Yes.
interesting that when Blunt and other spies, Blunt particularly, went to Russia, it was a carefully managed trip by the bureaucrats there, so they only saw, and in some way may have been reading his short-run psychology, short sort of diet. Could I just add that interesting criticism in Peter Geach's book, Reference and Generality, in the second edition, in which he trounces Keynes for his misuse of denoting as if it were a form of reference, in which he can't at all manage how to pick out sets, natural things, but has a fluffy use of metacentric denotion, and suggests that under the way he used it in probability theory in his treatises undermines his economics, but he doesn't go any further. Just
Something to look at.
just had an appendices. Hayek was an uncle of Wittgenstein. He used to round trains in both Keynes going around Europe. Fits in nicely about the row that Keynes and Hayek were having at King's College. Not least since underneath at the very same time Wittgenstein was teaching logic to third-year mathematicians and set theory in the mathematics chapters.
In the Chapel of Kings?
Well, not in the chapel. In the rooms.
Oh, right.
The ones that Russell used for his reasons.
Maybe I could make a comment about something in between the state and the individual. I recently talked to some French developers who are studying the concept of self-management. That was introduced by also under the name of some Lithuanian languages they are able to pronounce, and this is something like cooperative English, that is terms, I would say, of French, but it exists some middle model where you have the management done locally.
Yes.
So does that enter into this social welfare relation?
I don't know whether it has yet. one had, I'm not omniscient in economics, I'm just dipping my toes in, but I haven't yet found that. Please do. Yes.
2 points. Mathias sounds around in the autumn term and you're here. We want to get you together in a discussion with him.
With whom?
Mathias Sen.
Oh, yes,
Yeah.
okay, yes.
Very interesting. And the other thing is, have you read Harry Frankfurt's book, which came out last week? Inequality.
By chance, I haven't yet read it.
Well, it's as successful as his previous work entitled On Bullshit, which and it's very much
I should mention I've been in contact with a colleague who's he's employed in a business college, and he was interested in approaching economics from a constructive point of view. And it makes a difference when looking at these infinite streams of discounting value and infinite streams of infinitely many decisions. It makes a difference if choice sequences exist, and if you take a Browerian or a non-Browerian point of view, then it can make a difference. So he wanted to apply constructive reasoning to economics. Well, that aforementioned.
And does he get anything that's more believable?
I don't know. I don't quite know what he gets, and I don't know what you consider believable.
Yes, so what Alman does in the paper, and it's probably the first time that it was done in economics, is that he makes the assumption that in economics usually there are kind of players. That it's not that there are n players, but there's a continuum of players, a continuum of agents. And so then the different kinds of harmonies of balanced situations and utility functions, he assumes reasonably that have to be measurable, and he has a solution for, he has a certain set of equations for the existence of utilities which would explain this kind of situation where the players form a continuum in a nice way, and he has to take a projection there, and then he's in trouble with the measure. So projective determinacy would be good for that. Otherwise, his approach would be somehow lost.
Yes.
Would be stuck with non-measurable sets. But you talked about this social choice, and because there's a similar arrow assumed that there's a finite number of voters n.
Yes.
Finite number, and of course it's not true if you necessarily if there's infinite. So I don't actually quite remember what the situation is there, but I assume it is independent that CFC that whether or of CF whether the arrow theorem for holds for infinitely many players. Do you know infinitely many voters?
Don't know. I don't know.
It's essentially equivalent to Disson's ultrafilter, non-trivial ultrafilter on the mega. If you talk about mega many voters,
Yes.
then every the arrow voting system essentially equivalent to existing.
Oh.
Yeah. So
Okay.
it is. Yeah. So that's another
Choice you do.
another connection between economics and set theory.
Right, thank you. That's a good one.
Any other question or comment? Look at one comment. So you kind of linked the endometics point of view to microeconomics, whereas the microeconomics will be linked to exotrophics, as you call it.
Yes.
But is this so? This means that there are no examples, or you don't know of any example of some kind of use of set theoretic or recursive constructions in macroeconomics.
Yes.
Or
Not offhand, but well, yesterday I discovered on my laptop how many things I've downloaded and not read yet.
And then another thing that I find a bit puzzling, because the most standard book in microeconomics is the book by two authors. One is Andrea Mascolelli, the other one I forgot the name.
Yes.
It's called Microeconomics, which is used everywhere in the world. And strangely enough, Mascolelli did his thesis with Debreu.
Yes.
And but he also worked with Ullman in this round. So I think that would be a particularly interesting case of study. You know, whether I don't know about whether in this book there are any uses of any results or mathematics that go beyond Zermelo with choice, or they need at some point some stronger system to prove the results there. Probably not, because it's a rather elementary book, so
Yes.
to say.
I know one of the papers I cited, I know it said they were solved the problem raised by Mascolelli, but I have yet to get to grips with the details.
Right. Any other? Okay, well, thank you very much.